A function is a relation in which no two different ordered pairs have the same x-coordinate. Now, you've covered some of this in your Year 11 methods course. The idea here is that if we have a graph, if you had a mapping where you had 2 points with the same x-coordinate, then that would be a relation but not a function. And the set of functions is a subset. Every point must have a different x-coordinate. And that would have been taught to you probably via the vertical line test. That if you sweep a vertical line across your graph, it will cut at most once. We'll have a look at that again in a moment. If a relation is given as an equation and the substitution of any value for x results in one and only one value of y, we have a function. And that's precisely what would happen here. Now, on my graph, we've got 2 different values of x which give the same y, but that's not what matters. What matters is that each x value, when you put it in, gives us one and only one y value. So you don't have another part of the curve down here, for example. So, for example, y equals 3x minus 1 is a function. All linear functions are functions. As for any value of x, there is only one value of y. X equals y squared is not a function, since if x equals 4, then y equals 2, or y equals negative 2. And you should have a good idea of what x equals y squared looks like. It's a quadratic where the parabola is on its side, and then you've got a single x value that has 2 y values. In this case, when x is 4, y is 2 or negative 2. We can also show this diagrammatically. So what we have here is what's known as a many-to-one function. The domain, the set of input values or x values, is ABC. The codomain is DEFG. Now I've got codomain here, but in this course you will not be expected to know about codomains. Codomains are a set such that the range is a subset of the codomain. The range is D and E, and it's many to one because both B and C go across to E. The next one is a one-to-one function. The domain is HI and J. The codomain, again, I've got it in this diagram, but you won't be expected to know about codomains. KLMN, the range is KMN. It's one-to-one because every single value of x gives a unique value of y. So that's a bit like the straight line example that we had above, y equals 3x minus 1. That would be a one-to-one function. This is a one-to-many relation. Therefore, it's not a function. Why is that the case? We have this one value of x here that gives us 2 values of y. If we draw all possible vertical lines, we mentioned that, the vertical line test, on the graph of the relation is a function if each line cuts the graph no more than once, is not a function if at least one line cuts the graph more than once. So we can see here we have a function because any vertical line just cuts once. This one's a function, it's a many-to-one in this case, but it's still any vertical line cuts just once. This one's not a function because this vertical line cuts the graph twice. Given f of x and g of x, we may be able to form a composite function where we perform function g followed by function f, and we can do it the other way around as well, maybe. We write this composite function as f of g of x, I don't know why I've got the word of in there, I'll need to correct that in the notes, f of g of x, or fgx or f gx like that. You'll see all three in the literature, which is why I've written all three down. It means f following g. We can see the x is going in from this side, so it reaches g first, then f. So the function g is done first, and the output of g is then processed by f. This is shown in the diagram below. So I'm starting with x here, and it goes into a machine that says I double and then add 3, in other words 2x plus 3. This is the g function machine. The output from that then goes into the f function, which is I raise a number to the power 4. So if 2x plus 3 goes in there, 2x plus 3 to the power 4 goes up. Remember that in general, f of g of x is not equal to g of f of x, and we can show that with the very one that we've just had. So what we can do is instead, let's go into f first, and then go into g afterwards. So this one would be known as g of f of x, because we're doing the f first. X goes in there, I raise a number to the power 4, x to the power 4. I double then add 3. What would come out is 2x to the 4 plus 3, which is different to 2x plus 3 to the 4. Sometimes we're going to find that you can do f of g, but you can't do g of f. So as we work through this, there's a lot of things to bear in mind.